Hi class, in this module we're going to be looking at a couple of definitions. The first definition that actually shows up is the idea of a set. Now, when we talk about sets, we're looking at collections of items, and this is the actual notation. Let me give you a couple of examples of sets. So for example, the set that contains two elements, and in this case, the elements are 0 and 1, could be an example. Another example could be a set that contains 7, 8, 9, and 10. And let me give you another example. So the first two examples that I provide here, they have finite elements. And the idea is that you write the numbers in order, typically minimum to maximum values. But you could also have a set that happens to be infinite. So for example, maybe 2, 4, 6, and then it goes on and on. So the 3 dots here represent that there's more elements in the set, and technically I'm not writing more than that, but the pattern continues. So the next value here would be technically 8, 10, 12, and then it goes on and on. So in the notation of a set, if you put those 3 dots, and I'm referring to these 3 dots, it means that the pattern continues. You could also have a set that doesn't contain any elements. In this case, this is the empty set, and this is the notation of the empty set. So in this case, no elements. As part of the definitions, in this module, most of the work that we're going to be doing contains whole numbers, and by definition, whole numbers start at 0, and then it contains every integer afterwards. Other problems are going to have natural numbers, so the only difference on the natural numbers is that they start at 1. And notice that, well, both of these sets actually continue indefinitely, so they have the pattern that they go on and on and on. Let's take a look at another definition. Now, when they're referring to absolute value, it represents the distance of any number to 0. So the notation has vertical bars. So let me give you an example. If you have the absolute value of 10, this means how far is 10 away from 10. So this would simply be 10. Absolute value of 1, well, this is 1 unit away from 1. And all of these simplified. So whenever you have an absolute value, you're just referring to how many units that given value is away from 0. So let me just give you one more example. In this case, this is the absolute value of 10 plus 1. Now, you're not evaluating the absolute value until you have a single digit inside. So in this case, this is equivalent to the absolute value of 11. And then 11 is, well, technically 11 units away from 0. So our answer would simply be 11. It'll show up later. Might as well talk about it in this introductory module. The next notation that we have to review is what we refer to exponential notation. So if you have b to the m, you have m, well, times. And let me give you examples. So if you have 2 to the third, this represents 2 times 2 times 2. I'm not going to multiply it. I'm just going to leave it in this format. So in this case, it's factor form. It actually simplifies to 8, but I'll leave it like that. So if you have, for example, 5 to the second, this represents 5 times 5. So you multiply the base a total of exponent times. In this case, 5 times. Let me do another one. In this case, let's do 10 to the fourth. So you're expressing this one as 10 times 10 times 10 times 10. So the value of 10 will be multiplied a total of 4 times for that one. Let's talk about symbols. So this symbol here represents less than. If you have the less than and then a line underneath, it represents less than or equal. So less than or equal. And then if it's pointing on the other direction, it represents greater. And then in this case, greater than or equal. Now, let me give you a couple of examples. So some problems are going to ask you to compare. So for example, you could say that 5 is less than 7. That's one way to use the symbols above. You could also say that 10 is greater than 2. That's another way of using it. And then the ones that are a little bit confusing are these, because when it says less than or equal, as long as one of these two are true, the statement is true. So for example, 10 is less than or equal to 10. 10 is not less than 10, but it is equal. So in this case, that's a true statement. Or you could also say 10 is greater than or equal to the values of 2. So 10 is not equal to 2, but it is greater. So or means as long as one of them is true, the whole statement is true. So these two are a little bit confusing. As I mentioned earlier, they're going to show up in some of the problems as you move through the actual modules as well. Let's take a look at graphs of numbers. So here's the basic idea. When they want us to graph numbers on the number line, you're looking at the following. So you're first labeling where the values of zeros at. So I'm just going to put 0 here, and I'm going to say this is 1, 2, 3, 4, and 5. And they want you to provide a graph of the numbers. So your actual graph is provided by a dot. In this case, this is my dot. That's your solution for technically the values of 0. Here is 2. Here is 4. And here is 5. Now, I included more values in my actual sketch, like 1, 3. But they're not part of the values that they're asking us to graph, so I'm not putting a dot on those. So you can skip those, but you still have to put the slash to indicate that the pattern that you're using or the scale is equal. Now, let's take a look at problem 2. And in problem 2, let me just put 0 here, 1, 2, 3. Now, notice that you don't have the dot, dot, dot. So this one represents the first values of the whole numbers, which is technically this it here. But because you don't have the dot, 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 it only represents the first couple of numbers. So not all of them. So we're just going to put a dot on 0, 1 on 1, 1 on 2, and then 1 on 3. So your main solution is the dot on the number line. You cannot put the dot above it because it technically, if you put it above the number line, it represents an X and a Y. Those will show up later. Let's take a look at problem 3. In problem 3, they want you to graph. So technically, in this case, the absolute value of 5 is equal to simply 5. So this is 0, 1, 2, 3, 4, 5. And I'm not going to label the other numbers. I'm just going to label the solution. And notice that I'm not putting a dot on 0, since technically 0 is not a solution. You may include the other numbers that you have here. It's up to you. But on a sketch, that's all that's really needed. That's actually it for the first set of problems.